Hello everyone, my name is Yang. I'm a senior lecturer working at Bioengineering Department, Imperial College London. Also affiliated with ImperialX, Imperial College's flagship artificial intelligence center. Now you may expect to see a title of my introduction slides. However, I haven't got a good one. Then I reached out to this guy, ChatGPT, who is fantastic. Within 10 seconds, it gives me 10 amazing titles that are not only reasonable but also eye-catching. As you may infer from these titles, I work on AI in digital healthcare. Before I introduce AI in digital healthcare, please let me teleport you back to 2009, when I did this MSc project 15 years ago. What you see here is called texture synthesis. It is a traditional computer vision application that had been used a lot in classical video games. For example, games like Contra, which was very famous in 1980s, let some heroes carry machine guns shooting aliens. The background of these classical video games are synthesized textures, for example, grass, waterfalls, and rocks. The idea is simple, that we can collect a large library of textures with similar appearance but some variances. Research the texture patches with similar boundaries and then stitch them together to create large random-looking texture backgrounds. In my MSc project, we extend the texture synthesis method into face synthesis. Again, we collect a large library of face images. By using k-nearest neighbor-based AI approaches, we can find face patches with similar overlapping boundaries. From the top left corner of the face, we can then search and stitch image patches sequentially to create a whole face image. As the result shown, the synthesized face is reasonable, it's not an alien. However, you can find out that 3/4 of the face may belong to a male, and the rest of the face may be from a female. For example, you can see the makeups, and also the earring. In some more dramatical cases, that we can see some faces with part of the glasses, and one face can show different hairstyles and eye colors. These face synthesis results were far from perfect, but this was one of the earliest attempts on generative AI and its applications. Now let me teleport you to 2024. In February, OpenAI published some previews of the Sora, a text-to-video model which could synthesize realistic video by only using some text descriptions. As you can see in this short clip of a 2-minute video, the synthesized results are incredible. For example, the details of water reflection, movements of the characters, foreground and background rendering, and subtle leather texture details of the jacket wearing by the main character. Simply speaking, this is unbelievable. It demonstrates the exceptional development of the AI and in particular the power of the generative AI models. Let's play a real fake game now. In these slides, I show 2 examples of high-resolution CT images that's supposed to be collected from lung fibrosis patients. However, guess which one is the real data we collected from the NHS and which one is synthesized using generative AI models? Got the answer? Sorry, I may trick you. And both of them are fake data we created using generative AI. Such data can be very useful to augment our existing data collected from clinical studies, which can be expensive to gather. There are more applications. For example, some studies from Google DeepMind show that the AI can be useful for protein drug discovery and predict the properties of the proteins. In one of our recent preclinical studies, we can use generative AI models to synthesize multi-channel cell painting data from bright field microscope data. In summary, there are 3 pillars of my research group, including imaging, quantitative imaging biomarker extraction, and preclinical and clinical translational studies. Different from many computing research labs that focus more on objects and anomaly detection, I'm interested in reliable and reproducible quantitative imaging biomarker extraction, which can facilitate further preclinical and clinical translational studies. More importantly, I want to question the data quality first. For example, design novel AI and generative AI methods for innovative imaging sequences. In this case, we use AI to accelerate diffusion tensor cardiac MRI and enhance the data quality by denoising and motion correction. Our hypothesis is that such enhanced data quality can reduce hallucination and enhance the signal-to-noise ratio, in turn can produce more reliable and more reproducible quantitative imaging biomarkers, therefore can benefit downstream translational studies. My group is working on many different digital healthcare projects, including aging, cardiovascular and respiratory diseases, and cancer. Although AI technology are promising for digital healthcare, we can have some in-depth thinking. In one study by Stanford University, it shows that AI is now separating academia from industry because the latter has much more human and hardware resources. As researchers, we need to find out better ways to collaborate and keep abreast. Second, generative AI is powerful, but how to make it trustworthy, especially in digital healthcare, is a big question mark. Also, should we chase advanced AI or make sure data is more reliable with less pollution? Such balance will need more careful investigation. In digital healthcare, there always exist conflicts between privacy-preserved learning to ensure patient information privacy versus democratizing both data and AI technology. And finally, the goal of ethical AI is to promote safe and responsible AI use to mitigate AI's novel risks and prevent from harm. In AI-empowered digital healthcare, instead of only considering applications, we need to give attention to the first principle and understand the fundamental rationale of model development. I am now teaching image processing course at bioengineering, and also the trustworthy AI in medical imaging at EmpiricX. I'm looking forward to having discussion with you and also welcome students and researchers joining my group. Thank you.